Hey everyone. In this video I'm going to talk about measuring ideology and political polarization. And I think this is a really great example in the chapter because it shows that we're oftentimes interested ultimately from a theoretical perspective in measuring unobservable latent constructs. For example, ideology is a prime example of something that we can't directly observe, and so we need some measurement model to kind of quantify what we mean by ideology. We need a way to operationalize ideology and ultimately kind of make this kind of underlying latent construct observable, right? And so one way to do this is to use what is called the spatial voting model that kind of allows us to connect the underlying latent construct that we're interested in, which is ideology, to something that is observable, which is, in our case here, voting behavior in Congress. So congressmen's voting behavior when it comes to legislation, right? So we can use this ultimately to answer really important questions related to, for example, polarization. So, for example, if we wanted to answer the question, has the US Congress been polarizing over time? If we look at today's politics, I mean, this almost seems like a trivial question, but it's still important to be able to quantify how it polarized over time, to what extent it polarized, and to what extent maybe this process is also reversible, right? So ultimately, if we want to measure political polarization, what we need is a way to measure ideology. And one way in the discipline to measure ideology is to analyze roll calls, excuse me, to measure roll call votes of legislators in Congress, and use a spatial voting model to kind of make inferences about this underlying latent construct based on how legislators ultimately behaved. Okay. So here's a quick visualization from the book of how we can think of this spatial voting model. Suppose ideology can be characterized on two independent dimensions. On the one hand, we have economic conservatism and liberalism, and then on the other hand, we have racial conservatism and liberalism, right? And so in this world where ideology can be described by this on this two-dimensional in this two-dimensional space, we can basically place the status quo of the world somewhere in this continuum, in this two-dimensional space, and each individual legislator has an ideal point. So that's kind of where, if they had the perfect if they have control over the world, that would be kind of the policy outcome that they would prefer, right? Suppose one legislator's ideal point is here, and then there's a new proposal, right? A new law that changes some policies that has implications both for economic outcomes as well as potentially social outcomes, right? And so the idea behind this spatial voting model is that this legislator will vote for any new proposal that moves the status quo closer to his or her ideal point, right? So in the case of this legislator, every proposal that is closer than the distance between the ideal point and the status quo will be voted for, and every proposal that is further away than the status quo will be opposed, right? So this proposal right here is further away from the ideal point than the current status quo, so the legislator should prefer the status quo over this proposal. Okay, so that's a fairly straightforward framework. The underlying point is that we observe a lot of the voting behaviors of congressmen, and so ultimately we can this is kind of using something that is called item response, like a concept that is called item response theory. We can ultimately use people's kind of revealed voting behavior to make inferences about where they lie on this underlying latent scale, right? And so ultimately we do this by assuming that the probability of voting yes on a proposal is determined by this distance between a respondent's ideal point and the proposal squared minus the distance between the ideal point and the status quo. And that's the logic that I just went through. Someone should vote yes if the ideal point is closer, if the proposal is closer to the ideal point than the status quo, right? And so we can kind of quantify this as the difference between the ideal point and the proposal for the difference between the ideal point and the proposal, as well as the difference between the ideal point and the status quo for example, different types of proposals, right? And so ultimately we can then parameterize this by kind of estimating by observing how people ultimately voted. We can estimate kind of the unobserved characteristics with it, which is the ideal point of legislator X or legislator Y, on this latent scale. Okay. So we're not going to go into the details of that. Maybe later in next semester we'll talk a little bit about item response theory. But for now, it's enough to say that these types of models, which kind of relate the observable behavior to some latent construct, ultimately were developed in educational testing literature, where people were interested in measuring other underlying latent traits, like, for example, your math ability or your language skills, right? That's also, you could think of this as an underlying latent construct. And we try to measure this by asking people questions, giving them problems, for example, math problems, right? And so the underlying idea here in this educational testing literature is that people get a set of questions, and you can estimate their underlying latent skill as a function of to what extent they answer each of these problems correctly, and thereby you can scale all the respondents on the same underlying latent scale, right? And so the spatial voting model and these scaling models in political science kind of do the same thing, but they, instead of having math problems, the underlying observable outcome is policy proposals that have certain characteristics with regard to where they lie in this ideological spectrum, right? And that helps us then ultimately estimate people's positions on that ideological spectrum, right? So the equivalent of the test questions is the legislative proposal in Congress. And the equivalent of answering the questions correctly or incorrectly in the context of a math problem is voting on the proposal and saying A or yay or nay. And the equivalent of the ideal point, the ability in math, for example, is the ideal point on this ideological spectrum. So one very famous and set of kind of latent scores that are based on these roll call votes are called the DW nominate scores. And one of the data sets that we're going to work with now is basically looking at placing, or did exactly that. Ultimately looked at people's congressmen's roll call votes in Congress and used that to scale them all on a two-dimensional ideological position, which are here W nominate score first dimension and W nominate score second dimension. Okay. So based on that, we can look at, for example, the ideal points for the 80th Congress. So this is from 1947 to 1948. And specifically what we're going to do is look at the ideal points of Republican and Democratic congressmen in that 80th Congress across both dimensions. One kind of you could think of as the economic conservatism liberalism dimension, and the other one as the racial conservatism liberalism dimension. And I'm just going to go through the commands here briefly. First, we subset our original data set Congress. Sorry, this started on the previous set. We load this data set Congress first, and then we subset this by parties. So for one, we have Republican congressmen, and then we have Democratic congressmen. And note here how I'm kind of showcasing two different alternatives of how we can subset this. One is using the subset command directly, and one is using this bracket notation. Both ultimately are equivalent and leading to the same result. We're subsetting the data set into Republican congressmen only and Democratic congressmen only. Okay. Then within the Republican and Democratic subset, we're subsetting again to focus only on the 80th Congress from 1947 to 1948, and that is again using this equal sign, this logical statement that Congress is equal to 80. Okay. Then we're preparing the labels and access limits. We're just saving those in a separate object so that we don't have to type them out again and again, because we're going to create multiple plots and we don't want to repeat ourselves here all the time. And then first we plot the Democrats in the 80th Congress, and again this is a scatter plot, and we have a couple of additional options here. We set the size of the points, we set the color, this is the shape of the points actually. We set the limits of the x-axis, y-axis, labels, and the title of the plot as well. Then in addition, we add some points here. So this is just Democrats in the plot, and then we add Republicans using the points command, using red instead of blue, and using a different shape of points. And then we're adding labels within the plot, directly labeling Democrats and Republicans, right? And so the result of that is here in the 80th Congress, we have clear separation between Republicans and Democrats on these two dimensions. But crucially, what is important is that on each of those dimensions, we still have significant overlaps between Republicans and Democrats, right? So if we just look at one dimension itself, we see that there's still, there are Democrats that are more conservative than Republicans on the economic dimension, and there are Republicans that are more liberal than Democrats on the economic dimension. Same for the racial conservatism, liberalism dimension. And now we do the same thing for the 120th Congress. So that's the Congress from 2011 to 2012. Again, we subset Republicans and Democrats according to the Congress and according to the Congress number, and then create the same set of plots for Democrats and Republicans. And we see a much more clear separation. And importantly, this racial conservative liberalism dimension there's a little bit of a question to what extent we can interpret it as necessarily racial conservatism liberalism, but the point is that this dimension itself is not kind of a clear distinction between Republicans and Democrats anymore. But on the other hand, we have clear separation in terms of economic conservatism and liberalism between Republicans. So now we don't have any Republican senators that are more liberal than congressmen that are more liberal than Democratic congressmen, and we have and the other way around, we have no conservative Democrats who are more conservative than liberal Republicans. Okay. When we want to so this is kind of looking at the overall distribution. Ultimately, what is often decisive in these voting models is the party median. The median represents the measure of the party's ideological center, so that means 50% of the congressmen are more liberal and 50% are more conservative. And that's a very, in these spatial voting models, that's a very key characteristic where this median lies. And so one thing we want to do is kind of look at how far away these medians are, the median congressman is away from each other, and that gives us some kind of way to quantify the degree of polarization between both parties, right? And so in order to do that, we use the tapply command to compute the median for on the economic dimension for Republicans and Democrats, and then we create a simple time series plot where on the x-axis, this is now just the Congress number. The y-axis, we have the median that we just computed. We have some additional settings to make the plot look pretty, and I'll leave that up to you to kind of go through the code and see what these changes imply. And the resulting plot looks something like that, where we see that the Republican Party specifically is moving further and further, starting somewhere around the 95th Congress, moving further and further to the right on this economic liberalism, conservatism dimension, and the Democratic Party is also shifting to the left, but to a lesser extent. Okay. Lastly, of course, we can think about, okay, what are the underlying reasons that lead the parties to shift or to kind of cause this polarization? And one argument could be that it's related to increasing income inequality. All right, and so one way to measure income inequality is to use the Gini coefficient, which is kind of visualized here. It ranges from 0 to 1, where 0 implies that everyone has the same amount of wealth, and 1 has implies that one person basically has all the wealth and everyone else has nothing, right? And so the underlying logic is based on this Lorentz curve, which describes the kind of the cumulative share of people from the lowest to the highest incomes and the cumulative share of income earned. And so the underlying idea is, suppose you can kind of sort all individuals, all people in your population by their share of income, right? And then plot on the y-axis the cumulative share of all people up to that point, right? And so if this is just a 45-degree line, that means that every individual person has the same amount of wealth, right? And the further this line is basically, curved, or the more this line is curved, the more wealth there's at the top and the less wealth there's at the bottom of the distribution, right? And so how do we quantify this inequality? We can look at the ratio between the area that is here A and the area that is down here B, and the B, or the total area in this triangle, right? And so that's what the Gini coefficient ultimately quantifies, right? Is the rate of this A area above this Lorentz curve as a proportion of the total area. Okay. So in order to do that, we will look at the data of the US data of the Gini coefficient, so actually income distribution data, and this is just a 2-variable data frame with years and Gini coefficients for each year. And we can plot polarization and inequality over time. So we're just looking at 1947 to 2011, and we're plotting both the now the difference in median the median Republican congressman and median Democratic congressman to measure polarization over time and measure income inequality over time. Right, and so we see clearly those kind of the trajectories are quite the same. They're increasing very strongly after around the 1980s, right? And so we could also look at the correlation between those two variables, and we see they're highly correlated, right? But of course, correlation is not causation. It's the question is, of course, to what extent polarization leads to more inequality, or to what extent inequality leads to more polarization. All right, that's it for bivariate. For measuring ideology and polarization. In the last video, I'm going to talk about clustering.